Drinking water distribution. Explain why it is important to maintain a positive pressure within all portions of the distribution system and describe what can happen if pressure is insufficient. Answer: it is extremely important to maintain a positive pressure within all portions of the system, not only to serve firefighting and customer needs, but also to prevent contamination of the system. Lack of positive pressure can potentially cause contaminated groundwater to enter pipes through cracks. As well, negative pressure may draw contaminated water from unimproved source of water or backflow. What are some of the challenges to maintaining sufficient pressure or reasons why pressure might become insufficient? Answer: challenges to maintaining sufficient pressure can include excessive demands caused by firefighting or broken or frozen water mains. In addition, pump failures can create serious problems. List at least 5 components of the water distribution system. Answer: distribution systems consist of piping, pump stations, and storage facilities such as reservoirs, elevated tanks, and standpipes. In addition, there are numerous appurtenances such as valves, fire hydrants, meters, and service connections. List the most important operational objectives for distribution systems. Answer: operators of water distribution systems must ensure that consumers have access to clean, safe water while maintaining a sufficient pressure and volume to meet water demands. Describe at least 3 problems in a distribution system that could pose threats to public health and explain why. Answer: loss of pressure, low disinfectant residuals, leaks or main breaks, and cross connections could all pose a threat to public health because they could result in contamination of the water within the distribution system. Describe the purpose of storage tanks. Answer: storage also allows the treatment facilities to store water during slow periods for use during periods of high demand. In this way, the water treatment facility can be designed for the average day demand rather than the peak demand. Storage tanks and reservoirs are also used to provide the community with short-term emergency storage. The main distribution pipes within a system are known as, answer, trunk mains. Describe the purpose of valves in distribution systems. Answer: valves are used within a distribution system to isolate portions of the system for repair, cleaning, maintenance, or adding additional lines. Valves may also be used to regulate the flow or pressure of water within a pipe. Which parameter is very important to public health and must be tested regularly by the operator? Answer: chlorine residual from secondary disinfection. Why are distribution pipes flushed and how is this achieved? Answer: periodically. Periodically, the mains are flushed to remove deposits from the pipelines. Flushing is normally achieved by opening a hydrant. Describe how backflow can occur and why it is a problem. Answer: backflow is a reversal of flow within the water system. Siphonic backflow is caused by a drop in or negative pressure in the water mains. Back pressure backflow is caused through an unprotected connection to any equipment or device having a pressure higher than that in the water main. Backflow can lead to contamination of the drinking water system. Provide 3 reasons why a disinfectant residual must be maintained in the water distribution system. Answer: a disinfectant residual must remain in the water distribution system in order to continue to disinfect the water and protect it from recontamination, control biofilm, and serve as an indicator of distribution system integrity. Name different ways in which secondary disinfection can be achieved. Answer: secondary disinfection is generally achieved either by chlorination or chloramination. Why is it important to maintain and monitor secondary disinfection residuals? Answer: maintenance and monitoring of secondary disinfection residuals is important for the protection of public health. Failure to maintain sufficient chlorine residual in the distribution system has led to the outbreak of disease in some North American communities. Compare combined and free chlorine in terms of disinfecting power and how long the residual lasts. Answer: combined chlorine has a considerably lower disinfecting power than free chlorine. However, it is generally more persistent in the distribution system. Wastewater treatment. What contaminants are removed from sewage and wastewater treatment? Answer: the contaminants include solids, BOD, nutrients such as nitrogen, N, and phosphorus, P, which promote algae growth, pathogenic microorganisms, and harmful chemicals. What is the purpose of wastewater treatment? Answer: wastewater treatment is necessary because sewage contains many contaminants which must be removed or reduced before it can be returned to the natural environment. On the diagram, locate the main stages of wastewater treatment with an appropriate number. 1 for preliminary, 2 for primary, 3 for secondary, 4 for tertiary. Then write a 2 or 3 sentence description for the purpose of this stage, the main mechanism or process that occurs at this stage, and any significant pieces of equipment or infrastructure used at this stage. Okay, the first stage, preliminary treatment. Preliminary treatment is necessary to ensure that large objects or grit do not damage piping or equipment in the treatment facility. Sewage entering a wastewater treatment plant initially passes through a series of devices designed to remove or reduce in size large solids, grease, scum, and grit. Core screens, also known as bar screens, are used to remove large objects from the wastewater. Larger particles may also be removed from the wastewater by chopping or shredding in a process commonly known as comminution. After the screens and shredders, grit such as sand, eggshells, stones, and gravel is removed in grit channels or chambers. Primary treatment. The purpose of primary treatment is to remove large settable and floatable materials. In this process, sewage flows to primary settling basins, often called a primary clarifier, where flow velocity is slowed so that solids settle or float to the surface. Secondary treatment. Secondary treatment is used to remove dissolved or unsettled impurities such as BOD and suspended solids. Secondary treatment processes used in Ontario include the activated sludge process, sequencing batch reactor, SBR, trickling filters, rotating biological contactors, RBC, moving bed biological reactor, MBBR, and aerated lagoons. Like activated sludge process, these methods depend upon the action of aerobic bacteria to break down the solids and BOD, and as such, secondary treatment includes both physical and biological processes. Tertiary treatment. Some wastewater treatment plants also have tertiary processes to further treat the wastewater following secondary treatment. There are many different types of tertiary processes, but most involve physical chemical processes. They include chemical precipitation, reverse osmosis, carbon adsorption, filtration, and membrane filtration. Okay, so that's for the diagram there. The preliminary treatment, primary treatment, secondary treatment, and tertiary treatment. Describe at least 2 key variables that are being manipulated in wastewater treatment processes. Answer: oxygen and bacteria. Describe the objective of sludge treatment before final disposal and list 2 main methods. Answer: the prime objective of sludge treatment is to stabilize the sludge so that there is a low oxygen demand. The most common methods used for sludge treatment are aerobic and anaerobic digestion. Describe the main ways that aerobic digestion of sludge differs from anaerobic digestion. Answer: an anaerobic digester, anaerobic bacteria, those which do not require dissolved oxygen, break down the solids in the sludge to methane gas, carbon dioxide, and inert solids. In aerobic digesters, microorganisms also break down the sludge. Eventually, as food runs out, the microorganisms will use their own stored body mass for energy, resulting in a stable final product. List at least 3 secondary treatment processes and cite one that is most common in Ontario. Answer: activated sludge is the most common secondary treatment process used in Ontario. Other methods used include sequencing batch reactor, trickling filters, rotating biological contractors, moving bed biological reactor, and aerated lagoons. Describe 1 key way that a sequencing batch reactor, SBR, is operated differently than conventional activated sludge systems. Answer: SBRs, or sequencing batch reactors, are time-oriented batch systems rather than continuous flow through tanks. Describe the attached growth principle and name 3 systems that use this principle. Answer: the microorganisms responsible for treatment of wastewater are attached to some inert material instead of being held in suspension. Trickling filters, rotating biological contractors, RBCs, moving bed biological reactors, MBBRs, and membrane biological reactor, MBRs, are based on this principle. Describe what occurs when sludge is dewatered and list the common methods. Answer: dewatering is used to remove water from sludge. Often chemicals will be added to the sludge to assist in the dewatering process. Some common methods of dewatering include vacuum filtering, centrifuging, pressing, or drying beds. List the various forms of tertiary treatment. Answer: tertiary treatment processes include chemical precipitation, reverse osmosis, carbon adsorption, filtration, and membrane filtration. Describe in what circumstances lagoons are used and how this wastewater treatment process works. Answer: lagoons are used in many smaller communities within Ontario that do not use a conventional activated sludge process. Lagoons use physical and biological processes which occur naturally in ponds to treat wastewater. Within the pond or lagoon, solids settle to the bottom while algae and bacteria process dissolve organic particles. List at least 1 key distinguishing feature for each of the types of lagoons. Answer: aerobic requires oxygen for aerobic bacteria to break down organic matter, are generally shallow. Anaerobic does not require dissolved oxygen. Aerated, used for high BOD loads, increase oxygen content of the lagoon. Facultative, combines the features of aerobic and anaerobic lagoons. Relatively deep ponds, upper layer of water is aerobic, lower layer is anaerobic. Describe how wastewater is disinfected. Answer: after the secondary clarify, disinfection occurs, usually with chlorination applied in a contact chamber. Ozone and UV are also sometimes used for disinfection. And that is wastewater treatment. Pardon me, that is drinking water distribution and wastewater treatment.